What's up, everybody? Welcome back. Today we are working on our code visualizer. And today's topic is trying to get some form of hierarchy visualization in place. So, just to give a little feeling for current state, here is our code visualizer. This is a swarm of flies that that are trying to orient themselves in a way that makes sense for our image editor. So each of these little dots in this thing is a function or a type or a file or a folder, right? And what happens is they kind of have rules about how they navigate in this space, and they say, okay, if I call this function a lot, then like I'm probably tied to that guy in some way. And if I'm in this folder, I probably want to be like close by. And so they have like rules about how they like pull and push each other so that they kind of like orient themselves like this. And we have been working recently on kind of making it so that if I like were to say, okay, here's the text renderer, this red star here is the text renderer, who does he reference? And he kind of like propagates himself over here. He says like, okay, I like this guy, I interact with this guy a little bit, this guy over here a little bit, these guys over here. What we want to do here is we want to have some form of like actual usable information come out of this thing, right? So right now you can imagine you could put like a legend in the bottom right, and you could say red equals text renderer. Cool, right? But all of these things are kind of hard to glean info about, and so I think that you probably don't really care about like individual interactions with every single little thing, right? You kind of care more about like where kind of at a higher level are these like groupings of stars, right? So over here, like, what is all this stuff? What's all this stuff? What's all this stuff? And so my thought here is that I want to try to visualize some form of hierarchy in this thing. And then maybe we can focus parts of the hierarchy and add those to our legend as well in some way. Right? So there's a couple places that I want to like take like inspiration from here. I've been looking at like here is a folder like disk space usage analyzer of our of my work folder in this on this account. And so here what you kind of see them doing is they have like color allocations to different segments, and as you kind of like walk down, you kind of like take some segment of that color range, and I think that you could get like more, you could get like darker, less saturated or something here. But I like the idea of like having a hierarchy where you have things on top of each other that kind of have like subsets of a color space and some adjustment to them overall, right? I've also been looking at like pictures of like I've googled like space wallpaper. And I think that like it would be cool if we like backgrounded sections of the stars with like, I don't know, just like stuff that looks kind of like cool and spacey. We're not gonna get crazy here and say that like we actually care that we're like accurately representing something out of like a satellite would, or like a telescope would take a photo of, right? That's not really what we're going for. We're just going for something that like looks kind of nice. And so I think between those two things, we should be able to come up with something like kind of interesting, right? And so what I want to do is I want to first just start by outlining segments of this thing. Let's just do the dumbest thing and just draw boxes around everything that have like maybe some like grayscale like alpha applied to them or something. Then we can kind of see what groupings we see here, and then we can make like better decisions based off that. We will probably do some sort of coloring, try to make it so that like everything in one folder gets kind of one color. But I don't know, we'll see. Then maybe we can like maybe saturate backgrounds more as we move up, make the hulls prettier. That's kind of like the extent of the plan, and let's just jump in. So we have previously on our previous stream, we added some code that should allow us to make a convex hull somewhere. Based off of a set of points, basically, let's draw it. Say you have all of these points, bop, 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 and you want to like draw a background behind these things. Where does the background go? Is kind of like the question we were trying to answer. And so there are these things called like convex hulls, which basically say like, how can you encapsulate all of these points in like a blob, right? And I think the rules are that like you have to be able to access, like draw a straight line from any point on the hull to any other point on the hull. I'm pretty sure that's the rule, right? So for this case, it would be like kind of like something like this, right? What would not be a valid hull is like this. That would be no good. And because like if you draw from here to here, you go through a line, right? So you want like a blob that kind of encapsulates everything. So we have a way of generating these blobs now, and so I just wanted to see what happens if we group every item in our data set such that we can draw a hull of each thing. Maybe we'll see something interesting. So I think we had like in Viz, we had some sort of like hull update hull buffer who was called by hull finder. Hull finder, yes. Okay, so we initialize our hull finder and we put in the points for this hull, and then we run this guy until he gives us a set of points that we can use. Then I think we sorted those points and drew them or something. So we just need to make sure that we generate sets for everything we care about. So let's just start there. Let's start by generating a hull for just like top level items, right? So we said before that we have like files, folders, functions, types, right? You can kind of imagine that like if we were to process this folder image editor source, each of these modules will have no parent, right? GUI is an item in our thing, and he has no parent. Svimp is an item, and he has no parent. But the things down here, GUI source button, button make button is a function, and he's gonna have a node. Make button is gonna be owned by button.zig. Button.zig is owned by source is owned by GUI is owned by source, right? So if we just like kind of take the top level, I think that our thing is set up so that GUI is the top level element in this thing. We could look quickly at the DB and see if that is true. We can just go to GUI.zig here, and he does have a parent at 370, which makes this kind of hard. Oh, this is GUI.zig. Sorry, we want GUI. Yeah, so this guy has no parent, right? Which is good. So we can kind of like start by just drawing boxes around like each of the folders and just kind of see what that looks like. So I guess we're gonna have some sort of like hull buffer, probably. That seems reasonable. Where do we keep all of our other? So we have like one mega function here. It's because we keep tacking on to this visualizer without ever cleaning anything up. So we've kind of just been like, we're pretending we're in like long-term prototype mode. Just everything we do is just like tacking on more garbage onto the garbage. And eventually we'll find something we're happy with and we can clean it up. But for now, just everything's living in main. It's fine. And here we'll say we have some hulls. Hulls, baby. And we probably want to like make hulls out of the DB, probably. And I don't really know what these hulls are going to be. They're probably going to be like a list of hull, where hull is probably a list of points. So it's probably going to look something like this, like a double nested list of vec2s, which means that probably free hulls is reasonable in some way. That seems fine to me. Okay. Then we'll just kind of put this make hulls and free hulls over here. Make hulls. This guy has to return something. He probably has to take an allocator, right? Probably a DB. And he's gonna return a hulls. Sure. He returns a hulls. And then we had, what was it, free hulls? Which took in, I guess, can just take in hulls as a hulls. Hulls, 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 hulls. And on free, we're gonna like walk each of these things. And we're gonna call like alloc free on the hull, and then also on the hull's outer structure. Okay. Deck the hulls, mofo. Yeah, hell yeah. I think I had an idea. This might look cool with a little Fibonacci sequence somehow based on the relation. May end up with some crazy patterns. Oh, to get like the spiral, right? Like you're trying to get like something like this, probably. I think that I've seen something like that for Fibonacci. Yeah, if you draw it this way, right. It's this guy. Which does kind of make sense, right? Because if you look at like galaxies, like pictures of just like, you do see like this swirliness around there. So that's not crazy. Definitely trying to do some sort of swirly thing might be cool. But I don't really know. You'd have to like adjust the poles that way. You'd have to like, I don't know how you would like organize organizing structures that way would be difficult. And then also the convex hull idea doesn't work here anymore either. You would have to find some sort of like bounding box that's a little bit more intelligent. But it does seem kind of cool. We could maybe experiment with that in the future because that sounds more complex. I want to start with something simple. If the simple thing works and looks good enough, then we can just call it there, right? But for now, I mean, we'll keep it in mind. Okay, so to build the hulls, we probably want what? Probably an array list of array lists. Because we don't really know how big any of the sets are going to be or how many of them there are going to be. So we kind of do this at first. Probably unmanaged on the inner one makes things easier, but the outer one is easier managed, probably. And then like how do we get out of this? At the end of this thing, we probably do like another allocation at the end, which is builder items len long of const vec2. Okay. And then we go for builder items. We do like out at this index is equal to builder items at index to own slice, probably. And then at the end of this, we just say like for builder item, I guess it's yeah, items item item dinit. Yep. Okay, that seems right to me so far. Oops. Sure. Okay. Now we actually have to do the work. So we look at like items in the database, right? We have a node is ID, there's like db get node at this ID, I guess. Okay. We look into what we wanted to do initially was we wanted to just take the top level things. So we say like if node parent is not equal to null, we hurry the fuck up, move on with our lives, right? Then, what's this guy complaining about? Oh, this guy needs an alloc on this guy. Okay. Then we have to return out here, I guess. Okay. Then if we have a parent, this thing now, what? Like, builder dot append? How is this gonna work? I guess we iterate the whole database again, question mark? How do we find out, like, okay, our data storage format, all it has is like a flat list of nodes, and each node might have a parent, right? So this guy might parent this, and then this guy might parent this, and then this guy might parent this, right? And so if we're trying to build up a set that has all of these, we have to like recursively resolve parents, I guess. Yeah, so here I guess we say that this is like, this is the top level parent that we're looking for, right? And what we do now is we walk the whole database again, right? And we say, well, child IT next, we have some sort of like child ID, right? And we say if, what we do is we want to say like, if this thing is descendant of the parent ID, child ID with probably the DB here, then we append it to whatever we're putting in this thing, right? So we have like, we have this like array list of points that we are adding to this guy. Okay. Which means that we probably need like positions in here as well. But the positions change every frame. So actually, I think that this is going to be a list of node IDs. I think that makes more sense. So then we can just say like, who are my children here? And then we can resolve their positions every frame later. Okay. So that means that this guy's gonna have like, you know, we have like var children or descendants. And I guess that kind of means that here we can kind of just make the list at this point in time, which means this is like alloc free item here. Because we can then say like, okay, once we get out of this block, these descendants are freed because we're going to like move them out of this thing down here. We're going to say like builder append descendants to own slice like this. Yes. So at this point, we will say, okay, we've added all these descendants to this thing, which means that here we can just return builder to own slice. Boom. Yeah, simple. Simple. Okay, so now if we know this guy's a descendant of this thing, all we have to do is put him in the thing. So descendants append child ID. Simple. And now all we need to do is implement this. Maybe. I don't fucking know, man. So this is a db node ID. So is this, and this is a const db. We say var iterator is child ID while what, like, I guess like this is going to be a node, I guess. db get node of child ID while it parent is not equal to null. We say it is equal to db get node of child ID parent. So we can actually do it this way. We can do like while it parent db get node. This is parent ID, I guess. And we just reassign. Okay. Parent ID. Oh, that's true. Next ID. If next ID is equal to parent ID, which we can't do without doing value here, return true. Else, we get to the top and we haven't found it yet, we return false. Seems reasonable. Seems reasonable to me. Okay. So then this guy just needs an allocator here. And actually, this can be an array list as well. That's easier for us. We don't have to pass around alloc everywhere. This guy's a short-lived thing, so there's no point in, you know, pulling it out. And that's like a maybe. Okay. So that compiles. And it would be nice to see what the hulls are. So maybe let's just, can we draw our points by hull? So can we go like for hulls? can we adjust the color of the thing we are rendering by saying like hull positions is going to be an array list of vec2 initializer allocator, defer hull positions dinit. We can probably get away with some like well, we could reuse memory here. I'm not going to do that because that's work, but you could kind of like use like an arena or like do like a clear retaining capacity of this thing every iteration of the loop. I don't give a fuck right now, okay? For hull points, we're going to do hull positions, append. We are going to try to append, I guess, the position from the graph. So the graph every frame kind of like moves things around. And in here, we have, oh, we have the positions already here. Positions. Get at point ID. Okay. Cool. So that's this guy. Okay. So then here, instead of using, oh, this guy doesn't let me work on a subset of shit. But instead, what we can do actually, this actually might end up being easier. Can we pass in the hull points here so that the update node buffer, he's like, yo, I work on like full sets of data, but you can filter these with these hull points. Yeah. So this is db node ID. And then just here, instead of iterating over every single node, we literally iterate over the hull points. Okay. So this becomes a for loop here. And then everything else just kind of works. And color comes from this. So color comes as like vertex attributes on this thing. But for now, what if we just didn't do that? What if we just said, here's a color, use this color, please. Let's just do that. We can always come back later. Okay. So now how do we get a color? We go... we could do some like HSV shenanigans where we like pull a color from some ratio of the parent. That seems like we're probably gonna want that anyways. So we might as well, right? So like we can go like function, I don't know. So if we're gonna be want to do this on like slices as well, we're gonna have like some pie, right? And in this pie, you have like some split of stuff, right? And if we're trying to like subdivide this pie out here into smaller segments, right? It kind of means that we're going to have some sort of like start and end plus ratio plus L plus bald, whatever, right? But plus ratio, right? So we're going to try to like lerp from the start to the end, I guess, based off of size of the thing, right? So, and then you're probably going to want to like take like the center of the section that you made through, right? So if we're going from like, let's say we have like 3 guys, each with 1/3, right? And we start at, I guess we'll draw it aligned so that the first guy is on the x-axis, because that'll make it easier for me to think about. So this is 0. The first guy is like, 1/3 of the way in. So we're going to want to give him like a color value of this plus a range of this, right? And I think that makes sense here because the 0 point is also 1.0, right? This is both of these things. Yeah. So we say this guy gets 33% of 1.0, this guy gets 33%, this guy gets 33%, and then we find the center of their ranges. Sure. Okay, cool. So can we do like subdivide? Like find. We want like some way to like take a color space and find a certain thing's allocation. So I guess like we want to find like ratio range probably. So we're gonna say like you start here. You start with this many elements out of the total number of elements. Then your size is this many elements out of the total number of elements. And we are turning ratio range, I guess, right? And this is literally just like start and end, I guess. Right? So we say like this is start index, I guess, and this is size. Cool. So we say that the like start is the start index, and then we just like divide by the size. Cool. And then end is like size minus start divided by size. Yeah. Theme is it's kind of fucked up. If I turn on term GUI colors, it looks like this. It's the Sonic theme, I think, and then with like it kind of like 16-bit mapped into whatever Alacrity's default color scheme is. So good luck reproducing. So start is equal start, end equal end. And then if we're trying to do like allocate colors, like maybe like find color in like allocate color from range, I guess is kind of what we're doing. So we have like start is going to be like start hue. Okay. Yeah. End hue. And then what? I guess we'll kind of cover that part later. For now, let's just say we have like start index and size. And this is going to give us like a vec3. Okay. So we're first going to say, what is our ratio range here? Okay. And then can we just find the center here? This is literally just like self start plus self end over 2, I guess. Okay, so we have our const hue is just the ratio range center. Simple. Then we need to like convert this into RGB, which just like we've done this all before, but I just want to use like HSV to RGB, and we don't really care about anything but the hue. I want like the fucking formula. I know it's like something like there's like 3 sections, maybe 6 sections, and you gotta like interpolate between. God damn it! God damn. Oh, here. Yeah, this is basically what we're looking for, huh? But we don't care about anything. We know that everything's gonna be like fully saturated. But that's fine. Okay. Where is H in here? H over 60 mod 2. God damn it, god damn it, god damn it. I hate this. This is why we spent all that time on that color cube a while ago, because fuck this. But it's fine. Okay, const C is equal to, what the fuck is V here? So if we're doing HSV, we want saturation fully white, value fully white. We might as well just do the proper thing, huh? We might as well. And we'll call this normalize. I think is easier here. So here we have C is going to be the value times the saturation, which are both in their world 0 to 1. Cool. Here they say X is the C times 1.0 minus absolute value of H over 60 mod 2. So their H over 60 is 60 over 360, right? So this is what, 1/6? Yeah. Uh, so H over 6 mod 2 minus 1. Why mod 2? What's the mod 2 doing in this world? Because is this integer math here that they're using? This is doing some like fucked up math here, which we might not need. Like, what is this doing? C is saturation times value. So this is like essentially lightness. At the end, oh my god. Is there like a better formula for this? Bum 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 bum. Jeez. Oh, okay. So this is they're just copying from Wikipedia. I guess we could just do this. Oh, here. So they're trying to do like H mod 2. So they're trying to break this into 6 chunks. And then they're trying to do some sort of like absolute value trickery here. What is it? Why mod 2? Mod 2 seems weird. Oh, I see. Because they're trying to actually break it into 3 chunks. So this is 1/6, and then they're going like they're doing absolute value trickery. Sure. So F mod is what we want here. I'm pretty sure. So like something like this. Okay. Then this is gonna return like this is gonna return a vec3. Okay. What's the fuck is R prime in this? Oh, that's here. Yeah, okay. If do we have that H prime here? This is H over 6 in our world. If HP is less than 1.0, we do one thing. What was it? CX 0. I guess we don't return this thing because they have to do some sort of like multiplication. But these are just to convert into 255. So we can do C plus M and X plus M here. That should be fine. Then we just are like rotating these, right? So it's XC. Then 3, they have CX 0. God damn it, this is so great. This is so fun. I love this. Okay. Hold on. I want times here. I'm trying to get this in the range of 0 to 6, and we were 0 to 1, so that makes way more sense. Okay, so 5 was x0c. Okay, so like this, and then else it was c0x. All right. Cool. Cool, 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 cool. Okay. Let's do this now and just kind of see what happens. Okay. So here we have hull points len for size, and then like var hull index equals 0, and then hull index plus equals hull points dot len. Hold on. We need like total size here. Oops, oops. So the divide here is total size here and here. Yeah. Yeah, I don't know what the fuck I'm thinking. End is start index plus size over total size. I got confused by the multiple sizes there. Seems more reasonable. So this is now what? We want the start index, hull index, the number of points in this hull, as well as the total number of hull points. So what? We go like U size 0, and we say like for each hull, we look at like total hull points plus equals hull points dot len. Wow. Yeah, I think that's right. Okay, so all of this was just to try to see like color like this the whole graph segmented into a few colors. Was kind of what we were hoping for. So let's see it. Fuck. 1122 is pissed off at return here. Cool. Okay. That's kind of interesting. That's definitely interesting. So what we're seeing here, if this is correct, which it might not be, but if it is, what we're seeing is that like grouping by folder is not necessarily like a perfect grouping. Right? That's kind of what we're seeing here. That like a convex hull is like the wrong answer almost. Which is kind of sick actually. So I think that the first thing we have to do here is we have to confirm that this is right. So like if we look at like, okay, Svimp UI is blue. If we just, I mean, we should just fix, can we just fix the, can we just fix the mouse hover stuff? We could just start hovering over things and checking if they are right. Because if this is right, I think that this actually might end up looking more interesting anyways. Maybe. Because like if we were to do this, what we could do is we could almost make like a and use that in some way. I wonder if you could just leave it like this almost. Okay, yeah, let's just first confirm that these colors are correct. I think that'll make our lives easier. So we'll call this, let's just group every hierarchy just like at all. Holy shit. That took 35 fucking minutes? In what world? We were just fucking writing down groups of stuff. God damn, that's 30 minutes? What are we doing with our lives? Okay, let's say that we are at 40, 50, and we want to confirm correctness. So I guess to do that, we're going to do show hovered node. We have to do that. Which gets a little tricky. It gets a little tricky because we have like, yeah, why is this tricky? It's because we like lie about the viewport as we render these things. Okay, so I think that like the graph is kind of expecting to be drawn in some area where he has like -1 to 1 1 is kind of like the position in here. And then we kind of render this in like this. So we should just be able to like grab the mouse coordinate in pixel space, check if we're interacting with the UI in any way. If we're not interacting with the UI, then convert the pixel coordinate to a normalized coordinate in here, iterate all positions and see which one's closest. I think that's like, I think that's fine. I think we used to do something like this and then it kind of broke and then we just kind of like nuked it because we didn't think we needed it. But I think it's easy to fix. So where is our like UI stuff? Here, if action. So if there's some action from the UI, we do one thing. Else, we find the highlighted option. So I guess somewhere we're gonna have some sort of like some like top level variable for selected node, which exists already. Okay, and we already show this in UI actually. Okay. Is that shown in UI right now? If we look at this, do we see like, oh yeah, right here. It just says names render and then it just never updates. Okay, cool. So can we then walk all the positions? Okay. So we get some like node ID out of this thing. I don't know. Positions get ID. Okay. So this is the position of the node. We need to like convert the mouse position to normalized space. So mouse pause is gonna be like, do we like keep track of that anywhere? Mouse position. So we were like right mouse moves this GLFWQ. So we must have like some input state somewhere. I think it's in like a GUI runner input state. Hell yeah. Mouse pause. Hell yeah. Okay. So we need to convert this to normalized. So I think we just do like the mouse position minus the sidebar width, right? Because this thing is in pixels and the sidebar is on the left side. Okay. This is rel graph, and then mouse pause is going to be mouse pause rel graph over like the size of the thing, I think. So we're going to take like the X position, Y position separately, probably over, how does like our window stuff work? window width minus sidebar width, and window height. Yeah. Okay. Sure. And we could just kind of fold this all into one thing. So this is here, and then this is... That's fine. Yeah, that works. So we say, like, closest pause is infinity. Closest node is a node ID equals 0, I guess, for now. Then we rip the node list and we say, or the positions, and we say if position, or I guess dist is going to be position minus mouse pause length squared, because we only need to sort and length squared is cheaper to compute than length. We say if dist is less than closest pause. Closest dist, I guess, is more correct. Closest dist equal dist, and closest node is equal to ID, and then we should be able to say, like, selected node is equal to closest node. Wow. This is mad because, like, mouse pause cannot subtract sidebar width. Sure. Yeah, that's true. So this only applies in X, I guess. All right, let's see how that looks. Okay, so let's try to pick like something here. This yellow dot, very tiny yellow dot. Can we make them bigger for you guys to see? Just for now. Oh, we actually have that in UI. I forgot. I forgot we have a slider for that shit. Jeez Louise. Okay. So let's do that. Okay. So over here, all of this blue shit is GUI scroll bar. Yellow over here, we have scroll view. Is this thing like changing a lot? Update, get size. I'm not really convinced this is doing the right thing, to be honest. Like, I should be seeing like this thing change as I kind of wiggle the mouse around here. And I'm not. Right? Why is that not happening? Maybe we should check the mouse pause here. Mouse pause. Let's just check a little bit. Yeah, so top left is 0, 0. Bottom left, yeah, it's just, and then bottom right is 1, 1. Right, so we have to convert this to OpenGL space. So here we need to do, like, times 2 minus 1. And then this needs to be 1.0 minus this times 2 minus 1. Okay. I think that converts us to OpenGL space. We want, because it was doing top left 0, 0, bottom right 1, 1. We want bottom left negative 1, negative 1, top right 1, 1. So can we go back to logging that shit? Hello, where did that log go? Why did I fucking delete that shit? Come back. Okay. So down here, we're seeing 1, negative 1. Here we're seeing negative 1, negative 1. And then up here, we're seeing 1, 1. Yeah, okay, so this is working. So now if I start like wiggling over this stuff, I see the thing change as I hover over stuff. So that's good. Okay, so this is Svimp app over here. This is font storage, generated mask object, objects. What's all this? This is GUI pop-up layer on all of these. Oh wait, I forgot we wanted to make this stuff bigger so you guys can see it a little bit. So here we have like glyph atlas in text, highly coupled to the distance field generator in the renderer, which makes sense actually, because the glyph atlas uses the distance field generator to generate letters. So that makes sense. What about like this pink shit here? This is the math library. All of this stuff is math. Blue is GUI. Blue is all GUI. GUI, 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 GUI. Green is like GUI specific to the image editor. Purple is stuff in like the FIMP repo. Linter stuff, who cares? Main. Yeah, main. Okay. Interesting. So, also interestingly, this looks not as spaced out as last time, I feel like. But it's still not perfect. What is this? It looks cool. This is our attempt at mapping our code base. That is the attempt. So we're trying to say we have types, functions, files, folders. We put all of those in the graph. Eventually, we want to make it so that we hook this thing up to our image editor, and as we spend time in one section, he'll like highlight stuff. So if we wanted to highlight like the text renderer, imagine we're spending a lot of time editing the text renderer. Here we can kind of see like, okay, the text renderer gets like brighter, and he references like, we can actually see this a little better now. So this is the text renderer here. He's referencing like some stuff in he interacts with the text object in the image editor, as well as like the text object is part of object, so that makes sense over here. We see that he interacts with like the GUI text as well as GUI like as a whole. And then in here we're seeing stuff like TTF rendering he interacts with, as well as like the pixel converter. Yeah, it's kind of sick. Whoa, who is this Musu Pause fellow? Seems pretty popular. Yeah, he's going crazy over there. So I see. So it's a perf graph? No. Not performance. This is supposed. What we want is to provide at a glance info of where we are spending time in terms of edit time. So like in the past 10 minutes, what have we been looking at? And the idea is that like we're gonna put this in the corner over here, right? And like maybe, hopefully, we can kind of make it easy so that when somebody jumps into the stream to see like what components of our code base we're looking at. Okay. So this thing is correct. The colors are correct. And we do see that it's kind of stabilizing a little bit. But I do kind of still feel like the idea of convex hull is wrong now. Right? Because if we were to draw a convex hull around like the green section, we would draw this, like what's going to get generated is like kind of like this. And so no matter what we do there, that's kind of like a bad shape. So my next idea is maybe to look at, I wonder if we can generate a Voronoi diagram here, where each node kind of has to be within like many sets here, which is kind of interesting. Right? Like, we could kind of leave it at this level, to be honest. That wouldn't be crazy. But I would like to be able to say like, what is this? Right? We need some way, like when I hover over all this, I know that I hover over this and all of this is pop-up layer stuff. Right? But like, if we're working on the pop-up layer and we want to flag that somehow in UI, how do we, I guess we want like a bigger box, huh? How do we say we care about this? And like highlight this and give this like a node in some legend that says like pop-up layer, right? That's kind of what I'm imagining right now. That's impossible to read, but you guys get the idea, right? It's interesting that like heuristically, we could probably say that like the convex hull idea works for small groupings. But as we kind of get more spread out, that idea might work less. I mean, we might just think that though because of the fact that we're only looking at the top level groupings. Like it could be that we still see some sort of like intermingling around this stuff. So like what's here? We have like GUI selectable list, selectable list, selectable list. All of this stuff is selectable list. All of this stuff is also selectable list. What's this? This is the actual selectable list class. This is the label bounds iterator. And this is the list record. Okay. So like arguably we could say that like convex hulls might work for low level things. But that's not really what I want. What about... Okay, have you guys ever heard of like Voronoi diagrams? The idea of these things are that like given a point, you can say for each pixel in this picture, which node is closest. That's how they're coloring this, right? So there's like kind of like a hard line here, perpendicular to the line that goes through here, because at this point we go, right, this pixel we're closest to here, this pixel we're closest to this. We could do something similar for each level here, right? So we could kind of imagine that we would get like a Voronoi diagram at this level, i.e. level 0, we could call it. Our Voronoi diagram would look kind of like this, like I guess kind of more like this, and then like orange would kind of be like all like up in here-ish, right? And then we'd have like blue kind of, I don't know, like this or something. And then we could like use that to sample whether or not we want to draw like a fancy background in that area, right? And then we could just kind of keep going up the tree, right? We can kind of say, okay, so we're at level 0. There's level 1 now, which is going to be like, in our world, if we're looking at like text source text renderer, level 1 is going to be like almost the same in a lot of scenarios. Maybe you want to do it on like a per folder basis. So within this set, we just keep going down the set and making smaller and smaller Voronoi subsections. Then the output of the Voronoi diagram could be like, instead of colors, it could be like node IDs, right? So this blue section is all like GUI source, I think is what, yeah. Then what? Then like as we get up that thing, we just saturate the color more. Yeah. I kind of want to try that. So eventually I wanted to look at like, I want to make like a fancy background to this, right? You can imagine that like instead of coloring the nodes themselves, we kind of have like, I don't know, like the blue section of here or the purple section of this shit, right? And then these guys get like maybe a little bit tinted as well. And then maybe as we get like farther up the hierarchy, we go from like this into like this. Maybe is like kind of what I'm imagining. So maybe it's like a stopgap to see if like that color grouping would work at all. Let's just focus on the colors for now. And we'll say we're going to increase lightness probably as we walk down the tree. Okay. So that means I think that each, I guess instead of calling this hulls, can we just call this like, I don't know, like descendant tree or something. Oh, so over time you can record the graph changes visually. Exactly. Yes. Yes. So hulls, I want to call this. I don't know. We'll leave it called hulls for now, just because it's we already kind of did that, and we'll just say fix me, rename to something else. These are probably not hulls. Okay. So what are they? We need to store. Hmm. So if we're gonna do things where they increase in intensity, I wonder if you can get away with just rendering the points multiple times as like a level 1 attempt at this. So like if we were to render can we like open like who's gonna let me experiment with this idea? GIMP maybe, I feel like. So like I don't know. Can I get like a brush with low alpha? Is that like a thing they let me do in here? Can I not change the alpha of my brush? Is that not a thing? I thought it was, but geez, what am I looking at? What is this? Okay. Yeah, maybe alpha is not an option in here, huh? I just want something that lets me like maybe it's allowed in color paint actually. I feel like I've seen it somewhere. Alpha channel here. Okay, so if I do like alpha channel like, 10, right? And oh, what the fuck? That's not doing what I want. Okay, here. Okay, maybe even lower, right? So we pick like max saturation red, low alpha. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Like eventually that becomes closer and closer to the right answer, right? Kind of hand wavy. So if we were to kind of make the background here black. Hello? Paint bucket? There we go. Okay. Then like we take a red on this thing with low alpha and we just kind of like, that's not working. 10. Yeah, I mean, that could work. So then we have like points and we draw each point like one time at low alpha. Then we draw it again if it's like in the subset of points. Then we draw it again if it's like in the subset of smaller points. And we just keep doing that. Use my GUI. My GUI doesn't have alpha blending, I don't think, on the brushes, so I don't think it works. And then if I like really just like keep going, does this eventually turn like the color I wanted? Yeah, it looks like it does. Okay. Sure. That makes that's like makes for a really easy initial implementation, right? So now all we have to do is walk every point, every node in the graph, and walk its parent tree and add it to sets of descendants for all of its nodes. Yeah. Okay, cool. Cool. So we did this at some point, and then it's like sometime before now. And let's say that we are working on kind of like increase saturation as we move down. Oh, wait, that's not what I want. Fuck, that's not what I want. I'm a liar. I wasn't thinking all the way. So we wanted to actually color each. We were talking about like this earlier, right? Where we, as we go down, we like allocate from within the color range that this guy knows about, and we just keep allocating like smaller and smaller sub ranges of this thing. But that makes it hard to visualize without being able to draw backgrounds. Ugh. Okay. Okay, so like that doesn't really. What if we were to draw backgrounds then? If we were to draw backgrounds and keep going up the tree, what does that look like? So we kind of like color in this whole area turns cyan. And then we say, okay, what if, how would we color like this section of that thing then? Because we can't just Voronoi diagram that, because then the Voronoi diagram fills the entire section of like his parent, which means that we kind of lose like the overall background color of this whole thing. Maybe you could like fade it in though. Since Voronoi diagrams are just about like distance, you could kind of like distance threshold smaller and smaller areas. So maybe you could like you could say what is like the average you could still draw the convex hull, and you could say within this convex hull, what is my average distance to a point? And you could use that to threshold something. That doesn't seem crazy. That doesn't seem crazy. So you render a Voronoi diagram, which you don't actually have to use them as like the solid colors. You could basically just say distance to closest node plus the node. Then when you get like within a cluster, you kind of talk about, okay, well, how close am I like on average? What is a reasonable closeness in this world? Yeah. And then you use that to threshold something, and then you could kind of draw like these like platters behind these guys of like whatever color you wanted. Sure. Okay. I'm okay with that idea. Which means that let's just start. First of all, let's write that down somewhere because I'm going to forget. Current idea. Voronoi diagram for each what? For each item with descendants. Right? So we kind of consider this is one level of descendants. This guy also has some amount of descendants, right? We also find what is a reasonable average distance within a cluster. To threshold Voronoi strength, use Voronoi as mask to draw something interesting in the background. Okay, sure. Sure, that seems reasonable. And so let's just jump to step 1 here. Yeah, so this was like some point before now, which is 109 into the VOD. We were talking about like how the heck will we segment this stuff? And now we've decided that we want to do Voronoi diagrams at the very least. So let's try that. 01, 09, 45. We'll say top level Voronoi. Top level Voronoi. So we won't worry about like getting down the tree. I'm pretty sure that will work. I'm not too worried about it. And so we'll say instead of coloring in the nodes this way, let's try to find like nice little background thresholds, which we've done before. We've done this kind of. kind of. If we go into our image editor, where is, here we go. If we run our image editor, hold on, give him a sec, he's thinking. And we make a new drawing. And I guess we want to make this drawing based off like a constant color. Okay. We go in here, we do this, right? We have these like parameters that we can play with to like adjust the strength of a brush. So how the fuck does that work, right? How are we changing this like after we've drawn it? Well, this thing draws a distance field, right? And what this guy does is he says like, for each point or line, basically, how far am I from everyone else? And if I start just like clicking like this, it turns out that this looks a lot like this. Like a lot like this, right? Just kind of like with fuzzier lines. And what we did here was actually super fun. What we did here was super fun. It's okay, so if you have a set of points and you're trying to say for each pixel which point is closest to us, you essentially need to compare with every single point for every single pixel, which is like expensive as fuck. But you can like leverage the 3D graphics pipeline of a GPU to do this efficiently, right? Because if you draw each of these things as a cone, what ends up happening is if you like point here and point here, and you draw like a cone below each of these things, eventually these cones will intersect, right? And as long as the slopes of these two cones are the same, the depth of this thing, if you imagine that this is like 0, as you go down, like as long as like it's a linear slope and they're the same, the depth of the cone at that point is the same as the distance. And so what you end up happening is like these two things intersect, but the GPU kind of just like knows how to resolve that intersection and figure out which one's on top. So what we did for this was we just instanced cones all over the world and used their depth as the value. And I believe that we might be able to get away with just leveraging this thing again. There's like a real chance. It's probably not like perfect for what we need, but it's probably pretty damn close. So we have this like distance field generator thing. And in here, he must generate, generate cone here. He has tents because like for our case, we also had lines. And so like the distance from a line is like a Toblerone bar, right? It's like similar idea, just like different shape. But we probably don't need that part. Then what? We like generate this cone and we use instanced rendering to copy paste the cone all over the place, if I remember correctly. So here is probably the actual rendering. He creates a texture where he just says, here is my depth. Within this texture, he uses our program. The distance field has some sort of like masking for things that are inside or outside. What is this for? Oh, because this also does signed distance fields. Sure. Because in signed distance fields, you want like, this is your like your thing. You want everything inside to be positive and this thing to be negative, but still kind of be like distance to this line. So that's something that we don't really care about here. He calls update buffers, which this is probably setting the locations of all of the cones. Yes, okay. Makes sense. And then in here he calls draw arrays. And the program that he uses is literally just like, I have vertex positions, I offset by this amount, and then I stretch and I rotate. I think we don't need stretch and rotation in our world. I don't think. And then he outputs depth here. Do we use this distance field fragment shader? Yeah, okay. So what do we want to do? We want to do something like very similar to this, except our output needs to be IDs. We need to output IDs of nodes that we are a part of. Okay. Um let's start by copy pasting this whole thing into, dude, I don't know, Voronoi, like node Voronoi. I don't know, we'll figure it out. And I think he's probably going to be mad about the fact that he's kind of expected to be part of this like render thing. We can kind of fix this though, so we can say we import our rendering library. And then everything is kind of like a sub element of this guy. Okay. Then all of this should just work. So first, I guess let's just try to use this in its current form. Then we can try to adapt it for what we want. I think that makes sense. So I don't know how though. So this guy takes in like a point iterator and a sign texture, width and a height. And he outputs a texture that we can render. Sure. Okay. So let's first we'll rename everything to node Voronoi. Okay. I'm sure that this name will change later. Probably name will change. Okay. Then let's what? Just like try to generate a texture that has 2 points in it somewhere and render that somewhere, I guess. I don't fucking know, man. What are like the units that he's expecting here? Probably points are in OpenGL coordinates, would be my assumption here. Probably. And then, okay, yeah, let's just figure it out. So we'll instantiate this guy. Nope, wrong file. Import node Voronoi zig. Okay. And let's just try to instantiate this thing and see what fucking happens. Voronoi. Okay. And what if we just kind of off rip made it so that he doesn't render to a texture? Like, kind of just fuck all of this texture stuff. Just like literally render to the screen right now, please. Generate. So we'll rename this to render. And we just, okay, we do need depth testing. But all of this like viewport and scissoring stuff can go away. What's clear buffers do? This does need, ooh. Interesting. I think it's fine. I'm like a little less sure about this, but that's okay. We will see in a, yeah, because is he expecting to be attached to some frame buffer? Yeah, he is. So we just change this to clear color and clear depth. Okay. And then GL clear with color buffer bit and depth buffer bit. Okay, I think that's fine. So that kind of fixes this. We don't care about aspect ratio correction, which means that we can just write 1.0, 1.0 here probably. I guess we'll leave it. Yeah, what's calc aspect ratio? Yeah, it's literally just 1.0, 1.0. Okay. Update buffers. I guess we'll do this for now. And then we use an invalid texture for the sign. Okay. Then it looks like this stuff kind of will just kind of work maybe. What are like width and height used here? Color, texture, and depth texture. Yeah, so we don't make textures here. And we don't return a texture. We just render this shit to the screen. Okay. Well, we'll see what happens if we do this. I'm sure that we're going to have problems, but... And then I think that this thing doesn't need to return a failure either. Okay, so now all we need to do is, like, figure out what this, like, point iterator is supposed to return. So he iterates over these things, and he's expecting something that has a new line or line point. And each of these things is probably a vec2. Vec2. Yeah, okay. So we just need an iterator that returns points. Okay. We can make that work. We can make that work. So let's make like a fake Voronoi points for now. And he has a function next that he's expecting to use. It's going to return some item. And that item needs to have... It needs to be a union that has elements of new line of vec2 or line point, it looks like. Okay. This guy, I guess we're going to have like an index in here. And for now, let's just return 2 points and see if like we can like see them on the screen, right? So we're going to have like points here is going to be 2 vec2s, right? And this is going to be like the first one is going to be like negative 0.50, and the second one is going to be at positive 0.50. So these should be on like the center of the screen in X, and then kind of like quarter off in both in Y in each direction, or sorry, in X in each direction. Center Y, my bad. And then we literally just say like our initial size is 0. If self index is greater than or equal to points len, we have like, I guess we might have to be careful about like name collision here. I think it's probably fine. We return null. Otherwise, we just say return, and we want a new line. We're gonna pretend there are no lines in this world. And the new line is equal to points at self index. Okay. And then all I have to do is defer self index plus 1. And then we should be able to just like feed this motherfucker into update into, I guess this is now called render. Redefinition. Okay. Oh, because update buffers, sorry, renders here. Is the allocator used anywhere? Yeah, it is. Okay. Okay, so now we should just be able to call like Voronoi render. Probably we want to do this before we do UI stuff. So probably like here, we'll kind of just like clobber the graph with this thing. And I think we just go like Voronoi points is going to be a fake Voronoi points thing. And we pass this in by reference that he can call next on him. Then we need the sign texture, which is going to be render texture invalid. And hopefully that kind of fucking works out. Expected something, saw something. Oh, so this thing can fail. Okay, which means that this thing can fail. Okay, let's just try that now. Fuck. Running the wrong program. Running the wrong program. Fuck. Shader compilation failed. Little bitch. What's he mad about? He doesn't even say why. So he's mad at the distance field vertex shader. Somewhere in here, something's going wrong. So compile link program. check shader compilation at line 92. Sorry, at line 114. So the vertex shader is failing to compile. And we're supposed to write y. But instead we get like this. He's just like confused. Yeah, so he's just like, I don't fucking know what you're talking about, bro. Which is kind of weird. Do I need to like turn something on to make that work? Is it because, oh, is it because everywhere else I've written for 330 core? No. That's kind of weird. How come like other things aren't having that problem? Can I look at like any other shader that we're using here? Seems to be fine. If I were to copy paste someone else here, how do you quit and get back into Vim like that? Uh, Control Z. Control Z for background and then FG for foreground. Yeah, I mean, he still doesn't like that. That's interesting. So even if we use a shader that worked other places, oh, we probably accidentally instantiated Voronoi before initializing OpenGL. Yeah, yeah, so we have to do it here. I see, because he needs OpenGL context to be up and running. There we go. Okay, so that's a really good sign. That's a really good sign that we, like, that's a fucking negative 0.5 and positive 0.5, and then we see, like, the strong line here. That's very good. That's actually huge for us. So it means that, like, our copy paste of the distance thing into node Voronoi is working, and now we can just start, like, slowly chipping away at him until he does what we want instead of whatever he was doing. Import distant, like, copy paste distance renderer. I guess maybe we add -u. Okay. So now we can start like ripping out the shit we don't care about. So like tents, we don't give a fuck about like lines segments, right? We only care about like points. So like get this anything related to like tent in here, get that shit out of there. Okay, okay. Boom, 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 boom. Tent points, gen tent, get that shit gone. Buffer lens, update buffers. So this is just gonna return like the U size directly. This thing is just gonna return cone, offsets, items, len. Tent buff goes away. Tent transforms also dies. Get the fuck out of here. Get out of here, which means all of this stuff dies. This dies. This dies. Okay. So that should still work, except 69, he's mad that this thing is just literally like num cones here. Okay. Many deaths, yeah. We're going crazy. Okay, everything's still good. We still see the points. Huge for us. So now our point iterator concept probably is the next thing to go. So instead of using an iterator that returns line segments, can we just fucking like slam him a array of shit? Like it's literally just here, right? Cone buff set offset data. So we literally just like, we already have this cone buffer. This can just live externally and we can pass this thing in as like the cone buff is an instance rendered buffer here probably. Then somewhere we need to like bind him here. Okay, which means that update buffers is moved out of this thing. And probably this guy should write down how many elements there are. Okay. Then when we call update buffers, he says set offset data is this function here. Okay, so this becomes public. And then here he stashes num items equal offsets len here. Okay, so that kind of covers that. So then when we render this thing, we can say that we used like cone buff num items, boom. Okay, and then we just have to figure out how to like pull this thing externally. So cone buff doesn't happen here anymore. We instead make a function to export that guy. Probably. So can we just be like make cone buff? This does this. Okay. I feel like a peasant that's stuck into a Wizards conference where they're reviewing and developing magic spells and I don't understand a thing. But it's super cool with all the arcane text and different colors. Let's go. I think that that's I think that what I'm doing right now is very like context heavy. It's like I in my head know exactly like what I did before, which makes this a lot easier. So I'm not doing a very good job of explaining it either because it's like, you know, it's like refactoring boring. So I'm just kind of like letting it fly. And I think there's some benefit to that. But it does make it so that your perspective is probably not that rare. All right, what's he pissed about now? Unused function parameter allocator here. That makes sense. Which means that does this guy need an allocator? Surprisingly, no. Okay. No field name cone buff, so that's gonna be moving externally. And then we should be able to then let's pass in our like a Voronoi buffer here now instead. So when we make our Voronoi renderer thing, here we should be able to say like Voronoi buff is Voronoi make cone buff. Okay. And then we should just be able to like defer this thing, free that fucker. Does he have a D in it? He must, right? Oh, but it's not public. I see. And then I guess we like prop set his initial data. So, oopsies. Oh god. Oh, where the fuck am I? Oh, it's here. Okay. Set offset data, and we're literally just gonna be like, I assume that this takes in vec2s. Yeah, so we can do like the same thing where we have like negative 0.5, 0, positive 0.50. And then hopefully if we call Voronoi render here, we're just like chilling. No, this is a Voronoi buff here now. And this goes away. We need to intcast this. Fine by me. And then num items starts at 0 initially, I guess. And then this cannot assign to constant, so this is a mutable thing now. And then everything kind of works. So if we run this thing, does it still look okay? Oh, let's fucking go, dude. Okay, I was really worried that we went too far there. So we'll say purge. Okay, so now the next thing to do, mouse pause, let's fucking go. Yeah, it's just still sitting there, huh? I think somebody said recently, they were like, it wouldn't be a Sphero stream if there wasn't just like some printf spam that he wasn't looking at. It's like, yeah, I do just like filter that shit out. I think that like my brain is like pretty good at just like ignoring noise. And so like I think that type of thing would really bother some people, but I don't even notice it until you guys point it out, which is kind of fun. Okay. So I think that what we want to do here now is we want to change this guy to output like a object ID instead of a depth. We wanted to output an object ID and a color. But I think that we can probably purge this thing a little bit further, actually. I'm just remembering this like sign texture. We don't have anything. We're not doing like sign distance fields. So let's just kind of get that shit out of here. So anything that talks about like sign here, sign valid, like this sign mul, get this shit out of here. Okay, boom, boom, boom. Anything about that, because this was for, we're only distance fields now, which should make our lives a little bit easier. Okay. What is scale? I suspect we're not using this either, to be honest. 1472. What's he pissed about? Oh, because we took this out? Okay. Okay, we're still good. Huge win for us. And okay, so I think that this like stretch, rotation, and depth and stuff is literally only used, was only used for tent stuff. So they were using stretch and rotation because when we were doing like line segments, we had like some tent that we drew like this, and we were kind of like trying to like draw that between points here. And so like to do that, we kind of had to figure out like, oh, okay, so if the point's diagonal, we have to, and it's like really long, we have to like stretch this thing out and like rotate it a little bit, whatever. But I think all of that stuff is like not relevant for cone rendering. So I think that that kind of simplifies a lot of this like vertex code, where I think we can literally just say like use v pause here. I think. And then like what is scale used for? We literally don't use this anywhere, so we can kind of ditch that as well, honestly. So it's really just this? Okay. Yeah. All right, that's a lot simpler now. What are you trying to do? Guessing some 3D stuff? Oh, fuck. That's not good. Wait, we lost something. Oh, it's because this is V. Wait. I missed the. I lost the offset. Where did the offset come from? V pause. Oh, it's just V pause plus V offs. Okay. Then this is V pause XY probably. What are you trying to do? Probably some 3D stuff. Yeah, I will explain in like 3 seconds once I make sure that like I just need to keep my brain context till here. Okay, cool. We are trying to make it so that in our code visualizer, hold on, I can show it. If I just take out this render call. This, in our code visualizer, I want to draw a background that kind of represents which nodes are like in which folder, right? So we're kind of trying to say like this purple section here, I don't want like the stars in the nodes in this graph to be purple. I want the background by those things to be purple. And what I actually want to extend that to is not just that the background is purple, but the background is like textured with some sort of fancy texture that looks like something in the galaxy or something. But tinted with the color of folder. And the idea is that there's like each node in this graph is like some part of a file, right? So like this node that I'm hovering right now is in our image editor code base, in the object.zig file, in the save object class, in the data class text function. That's like kind of what I'm hovering. And so I kind of want to show like hierarchy in some way by like stacking backgrounds. But before we do that, we're trying to generate like the top level background, which is going to be like a Voronoi diagram, which looks kind of like this. Which says like essentially which node, which set am I closest to? And so we're trying to generate this right now by like kind of stealing some of our like signed distance field stuff that we did for our image editor and like adapting it to look a little bit more like what we are trying to make. Stretch and rotation are gone now. Okay. Which means that this guy doesn't give a shit about stretch and rotation. Okay, this guy doesn't give about stretch and rotation. This guy then also doesn't give about shit about stretch and rotation. These guys also don't care about stretch and rotation. And then this guy also doesn't give a fuck about stretch and rotation, which means I think we're probably chilling now. Yep. Okay, so this guy is still drawing 2 dots on the screen. Hell yeah. And I think now we're at a point where we could start adjusting this to try to output something else. So let's add a third point. Maybe we'll add like a few more points. Maybe not just a third one. Voronoi buff. So let's add, I don't know, like 0.1, 0.1, negative, I don't know, 0.4 and 0.0. What does that look like? And then let's put like, let's try to put some in the corners as well, maybe. So like negative 0.8, negative 0.8. And then we'll do positive, positive, and then we'll put one, I guess, in each corner. Kind of like that. There we go, yeah. Are we explicitly doing a Voronoi thing somewhere? I was skeptical that it would really translate it to any clustering idea directly. Okay. Yeah, why did I want to do it like this? I think at the top level, I wanted, oh, we don't really have a picture of this anywhere, do we? Here. At the top level, I kind of wanted to see something like this. Right? So like I kind of wanted to see like this whole area turns blue. I think that we can probably like maybe fall off. Like the Voronoi diagram generation also kind of generates depth. So we can kind of say like if you're within some depth of any point in your set, I want you to be flagged with this color, and then we can use that as like a mask maybe for some sort of like interesting background stuff. So and then like for subsections, we can kind of do the same thing, right? Within this cluster, as long as you're within some like sane distance of this cluster, then we can still kind of make the Voronoi diagram that would kind of make him look like this, right? But like the application of that Voronoi would kind of fall off once we got too far from that section, if that makes sense. That's what I'm thinking, at least. I don't know. We just got to play around with ideas. Okay. So what I want to do now is I guess I want to render. I want the output of the Voronoi to be cluster IDs, I guess. Which we have, again, examples for. If we look at our image editor, we did this recently in the image editor. Let's see if I can show you what I'm talking about. We had this idea of drawing integer textures. So here, when we wanted to make it so that like when I click on one thing, I click on like exactly that thing, right? And so if you're looking in the bottom right here, what you're seeing is like where my mouse is, we have object IDs rendered into this mask. So when I render out like 1 pixel at this location, and I say like which object ID was rendered here. And the reason we do that is to like handle like alpha and stuff, whatever. But at the bottom right, you're seeing like us re-render that object ID mask as like a colored thing. So I think that we could do something similar here, where we render like each segment of the Voronoi as like an object ID and then display it with colors after. And since we have this example, I think it's worth pulling from it. So we were like, I think that's probably in like the Svimp renderer. We probably have something like render composition ID mask. That looks a lot like what I'm looking for. So in here we make a frame buffer, i.e. render to somewhere that's not the main window. We create a texture of red integer 32 outputs, and we use that as the output texture for this thing. We don't have a depth texture here. We're going to have to use a depth texture in our scenario, so we have to be a little bit careful about that. Can we make a texture format depth here? Is there like, how do we like make depth texture? Interesting. Maybe we just kind of made it manually here. Yeah, we did. Okay, so maybe we fix that. We say, okay, reset the viewport, fill everything up. I need to clear that thing with like specific words. Okay. Then where does he do the rendering? Here. Comp ID program. So this guy has component ID fragment shader, and he just says, I'm going to output an unsigned integer. Here is the ID that I'm outputting. Okay. Sure. So what do we want to do? I guess we kind of want to tack on. We want to tack on some extra information to each offset buffer, right? So we have this like offset thing that's coming in per cone. We're using like, okay, OpenGL, instance rendering. The way that this shit works is we have like kind of drawn one cone. We have one mesh of a cone that has like a lot of vertices on here, right? All of these, it's made out of triangles like this. We kind of like create this cone and we just leave it there. We say this is 0.00, it will always be 0.00. Then we have the second offset parameter. And what's kind of tricky here is that you have like one cone buffer over here that's just like, you know, the list of data for all of my cone points. And then over here, we have like another buffer that is all of the like list of offsets. And what's kind of interesting is you can mix and match these buffers in a way where we basically say this, we iterate items of this list once every like 20 times. So for every 20 vertices, update this once. And what that lets you do is it lets you re-render these 20 vertices that make up this cone over and over again with extra additional parameters that are a little bit extra. Like that are like one per instance instead of one per vertex, which is how you would normally do this. So what we can do is we can probably in here say, let's make like a color thing here, right? That is attached to the vertex info, but we lie. It's not actually part of the vertex info. It's part of the instance info. Then we can probably pass this thing along to the fragment shader. So we can probably say like in vec3 color here. And then here we should probably be able to get away with like this thing times color something. That's what I assume here. Probably that's actually more like color times this is probably a better way to do what we want. And then all we need to do is figure out how to inject that guy. So this is like instance data. Let's rename this from offsets vertex buffer object to instance VBO. Okay. And now what we have to do is, I guess our offsets here are now no longer going to be a list of offsets, but like instance data. So this thing is like, sure, he's going to have offset in there, right? But he's also going to have color. Okay, and so now this thing is a list of instance data. Let's actually slow down. Let's slow down. Let's leave this the way it was. leave this the way it was for a second. Let's make sure that that still works. I don't think we really changed anything too much, but I just want to make sure that this still looks. Fuck. My life is so hard. Why does it never do what I want? Fuck. Vec2 cannot be assigned to type error. Oh. Out vec3 color here. We need to specify that we have something to pass along. Okay, so that's still working. Okay. Now, before we get crazy and start attaching color data here, let's just change the format of this thing to instance data. And actually, we can leave the color in here, but we'll still just keep going with instance data here. Then this guy, instead of his stride between elements being the size of a vec2, this is going to be the size of an instance data. This must be the total length of everything, which means that where the fuck is our stride? The stride must be here. It must be here. I'm not going to pretend I really fucking know. But if this still compiles after we do this, then we're chill. I mean, if it still runs correctly. So we'll say offset. What do we call it in there? It was offset, yeah. Okay, we'll try this, and let's also throw a color in here, I guess, for now. So I guess we'll just make it like, I don't know, a color so that we have like something to prove that this is kind of doing what we want. Okay, so if this still works, then we have successfully like added additional data to the buffer. It does not work, right? So we did something stupid and wrong and dumb. So let's be a little bit careful here. Okay. So this guy says, give me this array object. Here is the index of that thing. Okay. And I have 2 floats at offset of probably. Okay. What else is going on here? So we enable this thing. We say, hey, let's attach offset's index here, which is I think index 1, to this instance vertex buffer. Cool. Then later we're gonna put this shit in there. Okay. And we're gonna update this once per instance. Okay. Everything's looking kind of chill. I wonder if it was just that offsets thing. Yes, it was. Okay, so what happened here, I think, is that Zig probably reordered this struct so that the offset of offset in this is not 0. So we just have to make sure to tell OpenGL, when you look at this data, make sure you know what you're looking at. And I think now we should be able to like kind of figure out like the color location from this thing. So we should be able to say, okay, let's read some extra data, please. So where does he use like offs location here? He literally just says, oh, we have like an option for a default color here. That's kind of cool. It looks like. So we'll kind of make them red by default, I guess, and just kind of see what happens there. And then we should be able to make it so that we can say, yo, there's like some other shit in here, right? So not only do you have offsets, but you have colors, baby. And this thing is actually 3 floats at the offset of color in this structure. That's like a maybe that'll work. Okay, then this thing. Let's also start by not assigning this. Just to see what happens. Then this thing needs the color location here, which means that that needs to be passed in here. Okay, gen cone needs like color, which comes from color lock of v color probably. Okay, so nothing is happening here, but that's because we're not using the color here. So can we go back to doing color times squirt depth here? And see if this stuff all gets tinted red. That's what I expect right now. Which it is. That's really good. It's all getting tinted red. So now, if we actually try to assign this data, we should be getting the attribute data from the vertex itself, which we're not getting, but I was hoping we would. So somewhere we must have to like enable this thing. I don't see us enabling it, which is a little bit concerning. Position? What are like offs location? Whoever enables this thing. Nobody? Question mark? Offset. Instance render button, set mesh data. Set offset data here. So he says this stuff is bound here. Okay. Oh, here. We have to enable the color stuff. Okay, cool. So now these things are purple. And now what we should be able to do is we should be able to change the color of each of the points. And they should come out as a different color. So we should be able to go here and be like, okay, some of them are purple, some of them are white, some of them are red, some of them are blue. I don't know. Some of them are green. Some of them are cyan. And then, like, I don't know. We'll just leave a couple more white ones. I don't really give a shit. This is really more to prove the concept that we can inject color here. That's pretty fucking sick, man. This is exactly what I was hoping for. So there's definitely some weirdness here where I would have expected this line to be a little bit straighter, right? That's kind of strange. It could be that the precision of the depth buffer is not good enough to get like a really crisp line here. But also, in reality, I do not care that much, right? Because this is like, we're probably, the render looks more and more like your shirt. Good observation, good observation. Okay, yeah, so I guess the next thing here that we want to do is we want to render this thing out to a texture instead of this, and we want like the depth and the color channels to come out separately. I think that's probably like the easiest next step. Okay, so how do we do that? I guess this is a really good time to checkpoint. Voronoi improvement. Let's think. Fashion 101. Okay. Fuck my brain. So I don't know if I've ever done like dual output textures. That's like something that I haven't done before, but surely is not that hard. But it's hard enough that I look at the clock and it's like, dude, I guarantee, that I am going to have trouble with OpenGL stuff a little bit. And if I struggle with OpenGL stuff, that's going to turn into me smashing my head into my desk. And I would prefer to smash my head into my desk at 2 o'clock instead of 4 o'clock. So I guess this is a good place to call it. We do have like something here. Maybe to tie it off. What if we didn't render the depth here? Hold on. Yeah. Okay, hold on. This is definitely, we can do something with this. We can, we don't render the depth here. We just render the color. Okay. Which should make it so that we can arbitrarily color like this. Okay. And let's attach this to the instance data that we have right now. That will be a good place to tie this thing off. So let's go through, and we have our like top level hull data, we called it here. And so just for each of these things, we will render their background here. So we'll render the entire point buffer as white. Let's go back to rendering each point as actually white. So this is going to take in, we are no longer going to use the hull points or color here. We just have, we'll go back to rendering, we'll have like colors per star now, which I think was a bunch of vec3s, if I remember correctly. Then this was saying like, this used to be, iterator is like we iterate over the position data, and we go while it next, we have some node ID, and we get the color out of that thing. Okay, then we just have to make sure that we're calling this correctly, which I think was just like colors here. He's pissed because colors is not a array, it's a node associated data. So it was like this. Okay. Yep, so we should go back to every star being white now. Or being tinted. Oh, wait, hold on. We need to show the stars, actually. Turns out that you need to render the things you want to render. So we should go back to seeing the stars all white, unless we highlight one. Then that one gets highlighted red. Hell yeah. Okay, so we're back to where we started at the beginning of the stream. But now we should be able to say, give me each hull, and for each hull, we should be able to do like Voronoi buff, and we should be able to like do something with this. I don't really know what yet. So these are, we need some array list of like node Voronoi dot, like what is his like type here? This thing needs to be public, I guess, and then we have each vertex is an instance data. So this is like this. We make a bunch of these things, and var, this is going to be like Voronoi buff, I guess, the Voronoi data. So for each of these things, we assign the color that we got to this point. So we should be like Voronoi render here, the buffer that we get, and all we have to do is like update the buffer. So we say like Voronoi buff dot, actually before, yeah, let's do that. Voronoi buff. And actually, we actually want this to come out here, because we want to render all the points at once. Every single point we are rendering at the same time, or else the Voronoi will not like correctly figure out the collisions between the different sections. So all we do here is we go like Voronoi for hull points. We have some point, and we literally just like slap this into the Voronoi data. And it's like offset is equal to point, and the color is equal to color. And it should just kind of work, question mark. If we say then at the end of this, if we say Voronoi buff, set offset data with Voronoi data items, which is not named correctly, but will live. Looks legit, have a great night. Wait, if you stay like 3 more seconds, you might see something really awesome. Fuck. Positions get point. Fuck. Area unit using mark. Try. Fuck. Set offset data, expected area unit type found void. Wait. I put it in the wrong slot. I'm totally staying there. Then hell yeah. Oh, it's the try that goes here. Okay. Well, that's interesting. Um, I can't tell. I think it might be working. To be honest, there's like a non-zero chance that this is doing what we wanted. Let's make the colors a little bit darker because this is like mind-meltingly impossible. It is your shirt. Okay. Can we do like 0 0.1, 0 0.1, 0 0.1 here? Just make it like. We don't want it to be so fucking abrasive. Why can't I multiply? Do I have to write vec3 here? Okay, so now the question is this thing right? So we want to see that like everything that's maybe this is probably too dark now. I bet you guys can't really see that well. Let's do 0.3 here. And we'll make the point size bigger as well, which should make it easier to like okay. So the question is everything that is highlighted one color part of the same thing? So yellow, we're seeing text here, text, text. Everything yellow is text. What about orange? Orange, we're seeing render, render, render. Purple, we're seeing svimp, 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 svimp. And then back here, this yellow thing is text again. I think this is actually fucking working. Like, somewhat surprisingly, this is working. Now, the colors, obviously, shit, right? And the backgrounds, obviously, not great. And the jaggediness, also not great. But this is like exactly what I wanted. Because this is going to be like a good stepping stone to do something more interesting, right? Imagine that you just said everywhere that's purple, make some sort of like purple wispiness or something, right? You can do load relaxation next time to get rid of that. Yeah, hell yeah. I was actually also wanting to look at like, there's also a chance that I would want to do like noise adjusted UV coordinates on this thing or something. But we'll see. I think that's pretty solid for now though. Right? At the very least, we have gained some amount of information. Yeah, interesting. What like yeah, I think it's working. Hell yeah. Okay, thanks for watching, guys. I'm pretty happy with this progress. If you like what you saw, we stream most days around 12:30 Pacific time to 4 o'clock Pacific time. It is 4:30 Pacific time now, so we started a little late. So if you're watching live, you should expect to see us online between 4 hours ago and half an hour ago. If you're watching live and you're like, wait, but if I want to watch you tomorrow, but I can't be online at that time, that no sweat. Don't worry about it. There's a YouTube link in the Twitch description. We have our projects organized in a playlist. Right now we're working on this code map building thing. But there's other stuff in the backlog if you want to check it out. We're also working on this like image editor a little bit. We've done some like font rendering. We did like, I don't know, video editor, QR code decoder, operating system. There's like stuff in here if you want to check it out. If you're watching the YouTube VODs and you're like, these are 2 hours, you just said that it's like a 4-hour segment. That's because there is this segment 1232, we call it happy hour, and it's kind of like, if we were to leave our code base in the state we left it in today, it would not be very good to work on tomorrow. So we try to do some amount of cleanup or research or like kind of like just like side quests in that segment. So if you want to see those VODs, the VODs for those are on YouTube members, Patreon, or if you sub on Twitch, you get the VODs, or you can catch them live if you're online between 12:30 and 2 Pacific time. That's all the plugging. YouTube, peace out. Twitch, let's find someone to raid.